So we'll start very soon. So what is the interview they will ask? Okay, so first they will definitely which topic? Latch up, WPE, STI, LOD, EMIR, and antenna. So this topic I'll cover now. Okay, I'm just revising. Latch up, oil, WP mean oil proximity effect, shallow trench isolation, length of diffusion, EM, electromigration, IR drop, antenna effect. So this topic is the common question any interview they will ask. So this is new view only except Raya or people are new, Ajay, Ashok, Lemba. Okay, so first how to definition. So because we have only 1 hour, you will forget everything. So how to define very simple way all these things. I'll tell you shortcut. EM, electromigration. So name itself, electron will be migrate. Okay. So electron will where it will be transferred in the conductor, electron will be transferred. So let assume conductor it here attach a metal. So you apply some voltage. So metal is a it consists of atoms. So atoms are tightly packed. So when voltage you apply, so your charge will be element. So positive charges. So it will movement as movements positive ions will be collide with the atoms. So due to the collision, so these atoms will be start to move. Okay, so due to movement, what will happen? So at this 2 point require for EM, one is unidirectional. When will happen? Unidirectional and long period of time. First you understand the concept, then long period of time. So when you apply a voltage, DC means unidirectional, AC means alternating current. So positive, negative, both will go. So balance, it will be cancelled. That's a only one voltage. So one force will be given to long period of time. So what will happen? These atoms will move. So due to the movement of atoms, so its structure will be changed. So suppose this is a M1, nearer by another metal one is there. So these atoms will be start to move. Even here also some voltage you apply. Due to this, the atoms will be, there is a short will be occur because the atom is inside the metal, so it will be moved from one position to another. Due to this, short will happen, or sometimes what will happen, this cases atom, it will be transferred to here. Okay, there is also case, two case will be open, either short or open. This is a long period, so they have seen. So how to define? When a continuous means DC voltage or unidirectional voltage you applied across a metal for a longer period of time. Due to this, there is a short or open circuit happens. Short means, Rai, can you tell you are already previous? What is the cause will happen? Short or open? Short means the exact term is Hillock. This is the technical term you have to tell. And open mean void. This is the effect will come. Okay, so this PPT I'll share in the group also. Just go through all PPT now, revise this.
Sir, till now, how much have you covered, sir?
No, no, for them this is basic only. So sorry.
Like only electron migration were you saying
This
from
is
5 minutes or
yeah. This is the start. I just
miss any?
started. This is
Okay,
just
sir.
yeah.
So
So
can you me can you explain it once again, sir? Like just
okay, you
brief.
join now. Okay, okay, sir.
Yeah, yeah, sir.
I'll definitely explain you. So first to understand which point you need to prepare. So latch up, oil proximity, STI, LOD, EM, IR antenna. Because we have only few time. So I will give you brief idea means how to explain interviewer. So what do you know? Okay. So I'm going first EM, electromagnetism. E for electron magnetism. So electron migration movement. So movement of electron. So what is happening? So it is movement of a electron where it is happening inside the metal. So inside the metal, so I'm just taking a metal one. So you apply 2 point, you have unidirectional and longer period of time. So when you apply a voltage longer period of time, so electron will be generated. This is the ions. So ion will be collided with atoms. So due to the collision of ions at atom, so atom structure will be changed. So atom structure means in the metal or conductor, so atom are tightly packed. So it is called crystal structure. So I'm not going that much depth. So you go, so atoms are arranged. So due to the force, what will happen? These atoms will be go to little bit up. The structure will be same. It will be compressed or it will be expand. So when you will be expand, what will happen? So it will touch the another atoms nearby. So metal one will be there. You draw another metal. So when it's nearby metal, it will be short. And this short is called hillock. And there is a chance due to the movement of these atoms, so there is also open circuit also will be occur. So open circuit means void. So you can define. So finally, whatever if you just means without remembering anything, if you understood what when a unidirectional voltage applied across a metal for a continuous period of time. Due to this, there is a short or open circuit will be occur. Short means hillock, open means I'll share PPT first because you people will forget the group. I'll share this PPT layout dependent effect. So this effect every time they will come.
So,
So all the interview they will ask.
sir,
Yeah.
sir, could you also explain, like, in case of standard cell, how do we decide the number of tracks?
Yeah, that also I'll cover.
Actually, I have it. My interview is scheduled from 4. So,
Yeah, only 1 hour I'll take everybody interview after 4
okay,
only.
okay.
So let not because these people and all topic is not covered till now. So only your 16 batch, 17 batch. Okay, I'll cover that topic. No need to worry. Just for revision how. So EM, how to, so they will ask in the interview how to reduce this EM. So you have to remember 3 point. 3 point means increase the, I share PPT, just go through that PPT. Whatever I'm covering, it will be there. So first point is EM. Whatever I told, because that remember who short hillock, everything I given the diagram. Okay, now EM means current will be high. So how to avoid this? So you have to do increase the width. So one condition. Little bit faster means I'll directly show the PPT. See whatever I told in short, that is called hillock. Open means void. So this is happening. Nearby metal is there. So there is short means hillock. Open means. So this is the definition you have to tell. And how to save. So you have to two condition. Current will be minimized. So how it will be? One condition is you have to do parallel routing, EM avoid. If anybody doubt, you can ask. So parallel routing, second point width, increase the width. So if you take more increase, so resistance formula is seat resistance, already I told. L by W. Okay. So if you increase the width, resistance will be less. So more current you can pass, means more charges you can pass. So that's why it will not. And third condition, so as per the current density.
Sir, what is that formula?
R equal to, okay, first I'll derive. R is equal to rho L by A. So rho equal to length W into T. So width into thickness. So rho by T equal to L by W. Okay, rho by T equal to seat resistance. So that's why it is RSHS. And in last class I covered this one in the ALD 18. R equal to seat resistance into length divided by W. Any doubt?
No, sir.
Okay. So don't be hurry. So you just attend the interview. Even if you don't know, you can tell this type. Parallel routing, width increase, current density. Current density means, okay, current density means, so as per your width. So for this technology, you can assume 2 milliampere current, you have 1 micrometer width. So you can tell interview. So for our technology like 90 nanometer you are doing. So for this technology, we are following 2 milliampere current, 1 micrometer. So any current you can give. Suppose you want 5 milliampere. So how to find? Has to convert 1 milliampere. 1 milliampere equal to 1 by 2 micrometer. So 5 milliampere means you multiply 5. So 2.5 micrometer would require. So if you maintain like this, so your EM will not be affected. Understand? So this is the fixed value. 2 milliampere will be carry 1 micrometer width. So you can tell the interview, they can ask sometimes. Okay. EM is done. IR drop is same much. So if you know current, resistance if you multiply, that is called IR drop. How to calculate IR drop? So any devices, you have to measure the calculator resistance. Resistance how will calculate? So if you know seat resistance, length by W. Actually in real time you will get to know seat resistance. In this technology you don't have. Current if you know, so if you multiply IR drop calculation. This is the simply. Okay. Next is well proximity effect. So this is also okay. Before that I will cover antenna. Oh yeah, standard cell also I will cover. So one by one. So 2.2 already you cover. Then go to LOD. So which one small will cover. LOD means length of diffusion. This is your source. This is your drain. This is your gate. So this length and this length should be same. This is called length of diffusion should be same. If it is not same, what will happen? Suppose there is nearer by another device is there. So if you don't share. Share means one device you share. One device you didn't share. So if you don't share, what is that? In between, they will add insulator. Okay, this is what I am telling about matching device. So matching devices also they will ask why you need to do sharing continuously. So matching devices, okay, matching concept also they will ask. So okay, that also I'll give you some idea. So here oxide will be there, insulator will be there. So due to insulator, the force across this, it will be at more force, but here if you see there is no force. So here, okay, I'll tell you, try to understand this point. So here diffusion length is different. Suppose this is 1 micrometer. I'll give you a very simple way, so why I'll confuse you. If it is not there, so what is happening? So that's why you are maintaining. That is the thing. So one is length will be like this. This length is 2 micrometer. This is 1 micrometer. So if it is not there, what is adding? Oxide. Insulator will be there. Here also insulator is there. So what is happening due to the compressed force and here compressed force? So what will happen? Its very length will be decreased. Here also reduce, but there is a different uniform. Uniform length means source and drain are different. So you are passing a current, it will be carrying more number of electron because this area is more. But here 50, 100. So you are passing 100 number of electron, it is able to carry 100 number of electron. But here it is 50 number of. Due to this, a breakdown will occur. What is current? Current formula equal to J equal to I by A. Okay, so I directly proportional to area. So as for area increases, current also increase. But if you see here, it is not able to carry. So length of diffusion means both sides you have to maintain same. You understand? You are not able to, okay. Understand or anybody having doubt? Length of diffusion. There should be mismatch.
Sir,
I'm just repeating again. This length, this is 2L. Due to the mismatch of the length, so you are passing this is a source or drain. So you are connecting a devices. So it will be carry same current because it is series. So here 5 milliampere carrying. Drain also it will be carry 5 milliampere. So 5 milliampere is means electron will be 100. So here also 100 is passing. Here 100 passing. But see this much area it will not carry 100 number electron. But this much area it is more area it can carry. So one side it will be carrying, other side is not able to carry. Due to the device breakdown will be occur. Understand? Okay. Length of diffusion gone. Next go to
sir,
yeah.
what is the definition of this one, sir?
Length of diffusion means the diffusion length of a source and drain side should be equal. That is called
Okay,
length. Yeah. I'm going for antenna effect. This is very common. Okay, so antenna effect, when you antenna means in your home antenna net, long net. So when long metal connected to gate, long metal connected to gate. So what will happen due to this? So when it will be occurred during the plasma etching is two type. One is dry etching, another is wet etching. So dry etching, one term is called plasma etching. That is, you have to tell this term. So at the time of plasma etching, so when a long net is connected or long metal is connected to gate, due to this the ions will be come. So it will be enter to your gate. And this is gate or channel are isolated. But due to the more number charges, it will be enter to your isolation region, mean Si2 region, thin isolation region. This is polysilicon. So your device will be breakdown. This is called antenna effect. Again, I'm repeating, during the plasma etching. So when long net is connected to that net means here in this metal. So when usually etching will be occur, etching means removing your Si2 layer. So I told you initially, so when the fabrication time, that if you tell it will be time, but remember directly, you don't have time. Plasma etching you have to tell. So you can tell this is come under dry etching. So at the time of plasma etching, so when charges due to the plasma etching, more number of charges will be generated, and that charges will be entered to the metal, because metal is a conductor. So that charges will be entered here to damage your gate. Okay. Main interview asks how to avoid this. So first point is you have to calculate antenna ratio. Antenna ratio is metal area by gate area. Okay, so some technology it will this value is given, so 100 or 1000. So you have to maintain less than it 1000. So you have to calculate metal area, gate area. So gate area is fixed, metal area you have to change it. So change, how to change? You have to reduce this metal. So how to do? You have to delete little bit. Area means length into width. So you have to calculate length and width. You have to reduce. Like this also you can do. This is the antenna effect. How to reduce this? This is the first point. If there is condition, you are not able to reduce this metal area. Understand, I am repeating antenna ratio. I have shared the PPT, it is there in the, it will be faster because instead of writing. EMIR already completed. Just go through PPT. This is very important. So antenna effect during large amount of charges in plasma.
the group.
Sorry,
Please share this PPT once in the group, sir.
already said na.
Okay.
You check in the group. See, this is the metal area by gate area. How they calculated? So this is your metal connected length into width. So to 90 nanometer 205. This is multiplied. This length and this width. This is the gate area. So metal area by gate area. So it is 1025. But in the PDK it is given 1000. See, it should be less than 1000. So antenna will be occur. So if you maintain less than, that is the one reason. Second, if you are not able to do, use jumper. Second option is jumper. Jumper means jump to higher metal, next higher metal. Suppose you connected M1. So you have to jump for higher metal. Nearer to get only you have to connect. So this is called jumper. Okay, for time being you understand why higher metal. I'll tell you later if time permit. Third option is antenna diode. This is just remember because you have short period of time. I'll come to last. I'll come jumper antenna diode effect. Understand? I'll just repeat this point. What is the first antenna ratio? Second jumper. Third is antenna diode. Jumper means you have to jump from. Suppose M1 is connected, you have to jump M2. Next higher metal. Antenna diode. So diode will be okay. For diode, how to explain you? So this is connected. Okay, diode thing I will explain. It will be less time. Jumper it will take time more. The charges does not mean that only positive and negative charge also will be generated. So when more positive, okay, here source, this for I am telling for NMOS. So NMOS generally connected to VSS. That why it is like this. So it is be connected to your body is your VSS. So VSS means 0. So when more negative charges will become, okay, I'll give you normal condition 0 for 5 volt. It will not affect anything. Suppose more voltage, charges mean it will terms of voltage only. So more voltage is coming means more charges will become. If you 0, here -1. So this diode will be forward bias. It will be like bypass. Means charges will not enter to here. It will forward bias. Forward means anode potential greater than cathode potential. Anode potential is 0. Cathode is -1. But in normal operating condition, if you are sending 1 volt, so what will happen? This diode will be reverse biased. This is for NMOS. For PMOS, understand or anybody having doubt? Any doubt? Okay. For PMOS you connected, your body is connected to VDD. So this diode will be like this. So this is your 5 volt. Normally operating condition, it will not. If you more than 5 volt, like 6 volt, this will be forward bias, it will be transferred here. But you can save your this actual active device. Okay, so this is called your antenna diode. So 3 point antenna ratio, jumper, antenna diode. I'm just repeating this topic. Don't forget in the interview. Then come to WP. Well, proximity effect. So this is occur. At this point, they will not asking interview. I'll go to this one last also. STI is simple only, so no need to worry. STI means suppose two devices are there. So in between SI2 layer will be there. So if this SI2 layer to isolate, because there is here to here, so you will put SI2 layer little bit depth. Depth means little bit trench. So you will create a hole and you will inside some oscillators, but it will be more depth. That is called STA. So T for trench isolation. So isolation will be little bit depth. That will be called STA. So that is very simple way. So this is how what is happening. Why we are using STA? This is giving isolation between two active devices. Because what is happened due to the, if you are placed near by near, there is a chance this electron will be transferred to here. So it is like an isolator between two active devices. Okay, so if you have any doubt, you can go through this PPT now. That is called STI. So this is how they are making drains. Here they are using an outside layer. This is your STI. Length of diffusion, mechanical compressed step, inducer boundary. Okay, solution. Okay. Add dummy both side. I'll tell you that point also. And you will complete WP. All topic will be covered. So before coming to WP, well, proximity effect. So they would ask you what is dummy. So I didn't cover. So dummy means device always in cutoff region. So if you sort source, drain, gate, everything, and body, it's all sorted to one point. So what will happen? What is the condition? VGS minus VGS should be greater than VT, active region. So VG equal to VS, gate voltage equal to source voltage. See, this is gate voltage. Everything is sorted. VG equal to VSS. The difference equal to 0. So 0 will never greater than a some value. It will always less than. So that is always in cutoff region. So this is called dummy. So why we are adding dummy? So before that, we need to understand matching. Everything is bouncing except Raya. All are getting point what I am discussing.
Yes, sir.
Okay. So why you need matching? So matching just to understand the variation, VT variation, to avoid VT variation, threshold voltage variation. Suppose more number of devices are there. How to place them? So more number of device means there is just 6 devices are there. So how to arrange all this? That's why we need a matching. And all VT variations should be same. VT means threshold voltage should be same. Means all devices will be turned on at a time. So that time we need matching. And how to matching definition to avoid mismatch is VT variation. And we have to maintain two conditions here. Okay, for matching PPT also I'll share you. Okay, you have, suppose they will give you two devices are there. So matching generally when you do, that is current mirror and differential pair are there. So I don't have time to explain current mirror. Current mirror means okay. Anyhow, we can discuss. So current mirror means If gate and drain is sorted, that is act as a current mirror. Any for PMOS or NMOS. For NMOS, gate and drain. This is for PMOS. For NMOS, this will be your gate and drain. So gate and drain is sorted. This will be acted current mirror. Current mirror means, so you connected anything to get connected device. Gate and drain is sorted. So this device I connected. So whatever this current, it will be mirror. Mirror means here also I1. Understand or in doubt? So all connected. So here also I will connected gate and drain. So that is the point you have to remember. That is called gate and drain. Understand current mirror I kept like. So when you do this type of, okay, let's come to this point. So you have A, B, C, three devices there. So how to place in the layout? That is, you have to plan. So current mirror device, you have to place center B and C. So here A to B, A to C distance same. So all will be turn on time. So this is the example I'm giving. But you have like A equal to 2, mean 2 multiplier. Multiplier finger, you understand? Okay, another concept, multiplier and finger. In simple way. So multiplier just like a parallel concept. Finger just like a series concept. So single series means this is the width, this is the width, or W by 2, W by 2. So this is 2 finger means, so width will be divided by 2 times. But if you given this device having 2 multiplier, same, it will be just a copy, replica. So L will and W same, L, W same. Okay, so if you add W by 2, W by 2, so it will be W. That's why it is called series concept. Multiplier just a parallel concept. So this is the concept multiplier. Understand or in doubt? Multiplier means parallel, finger means series. And here, how many fingers you want? And what is the advantage? So current will be divided multiplier. Because parallel concept. And here finger means voltage will be divided. Okay, so now come to matching. Matching are 2 types. So okay, so we have time. Only matching, then antenna, if that then latch up I'll tell you, and WP. That 3 concept will be tell at least your 70% interview will be in that topic only. So matching is 2 type. One is coaxial, another is common center. Interdigitization. Second is common centered. So interdigitization means you have to matching in one axis. One direction means either one row, one column. That is called one direction. Here this is 2 dimension. X and Y direction you have to matching. That is called common centered. Only one direction. Understand? Interdirection and common centered. So common centered matching having many properties, but all the matching, what is the important point? Poly spacing should be same. So poly to poly spacing should be same. So this point you have to tell poly spacing should be same. So matching minimum condition. Any matching you will do. Okay. Any doubt?
Sir, what is the definition of matching?
Matching, it is just to avoid the mismatch of VT variation across the devices. So we need to do matching. VT variation, understand? Threshold voltage variation. You can tell that. You can tell that.
In order to avoid VT variation, we have to do matching.
Yeah, mismatch of the VT variation. Mismatch of the
Okay.
VT variation is the main point. So there is also, you can tell another point, process variation. Process variation
Process variation.
process variation called, like we have fabrication. This is related to fabrication. So fabrication, you have all point you can tell, like photolithography, etching. These also all come, but main is the VT variation. So that's why I share one PPT. Oh, I didn't share in the group. You can go through this. Okay, so main will command centered. Interdirection, suppose 4, 5, A equal to 4. They will give you directly A equal to 4 means A 4 multiplier, B equal to 4. Okay, so you have to do interdirection. How will do? Like A, B, A, B. This is only one direction, one row, one column. A, B. So if you see A to A distance, all are same. B to B distance, all are same. So this is called your interdirection matching. Any doubt here?
Sir.
Second point is common centered. Common centered means first quadrant equal to third quadrant. First quadrant equal to third quadrant. Second quadrant equal to fourth quadrant. So if it is A equal to 4, B equal to 4, you kept A, then B. Okay. This is second quadrant equal to fourth quadrant. Then if you press B, A. Somebody tell I can do like this. Here both are correct, but which is the more dispersed, that will be preferred. Dispersed means, see, the orbit dispersed, all are arranged in properly. So this is only one direction you arrange, but here all dimension you arrange. Understand? So this will be more preferred. So one term is dispersion. So it will be dispersed. So for that matching concept, I share PPT now. So it should be symmetric X and Y axis. The first current equal to third, you can tell fourth current. The first current equal to third, second current equal to fourth quadrant. See, the matching in maybe different concept, mismatch. Let's circuit like pair, VT variation is important. Circuit use this to avoid the VT variation. So matching two types, interdirection and common center. Okay, so you have 4 point: coincidence, symmetry, dispersion, compact. So compactness means it should be square, so it will square or rectangular. So this is the term. Don't keep, suppose a equal to 1, b equal to 2. So this is not in the proper domain. So a equal to 1 means here, so b you kept like this, but you should not kept like this is blank, so you have to add a dummy. This is same, and dummy with length should be same as a. Understand? So you have to make a compact. Compact means either rectangular or square. Dispersion should be proper. Dispersion I told you. Symmetric. Symmetric, first quadrant equal to second. X and y axis symmetry. And this should be coincident. Coincident means your center. From this center point, you have to take some center point. This is the coincident at the center point. 4 point. Again, I'm repeating: coincident, symmetry, dispersion, compactness. If you need doubt, you can take a screenshot of this PPT. Matching. Any device you tell, they will give you common center and just try to do a first quadrant equal to third quadrant, second quadrant, fourth quadrant. Actually, we don't have time. I will give you more. We have only 10 minutes. Okay, so before that, Raya asked that question. How to?
What's the number of tracks? How to decide that?
Yeah,
In
number.
our case, like,
Okay, so first point, what is standard cell height? So first to understand number of track minus 1 into pitch. Okay, so track, this is term. Pitch means, suppose this is just an inverter. So take an example. So when they will ask any device, this is your PMOS. This is, okay, let it, just take an inverter. This is inverter you did. This is the standard cell height. Standard cell height means exactly your center point of a tap to this point. So this is called your height of a device. Okay, so track means this is generally in the standard cell we will follow. Normal analog people will not follow. Standard cell layout people will do. So these are track. So track just it will give you the layer, only metal you have to draw on the track. Track nothing else. This is just a invalid layer, you can tell. Like it is like you're not useless thing. Means layout will not identify. If you draw how many tracks, anything. If you run DRC, it will not show anything. This is just a marker layer. You can tell it. This is a marker layer. Above this, you have to draw a metal. Suppose you have to draw a metal. So M1 you draw. How many metal? Total 6 metal you draw. So 1, 2, 3, 6. So this is also 6 track. And your pitch. Pitch is center to center distance of a adjacent metal. Adjacent means don't tell this metal. Adjacent, nearer by metal. But let assume your adjacent metal distance is 1 micrometer. Center to center. And number of track is how much? 3 into 6. So 6 into 6 minus 1 into pitch. So pitch how much? 1 micrometer. So your standard cell height is 5 micrometer. Okay. Suppose you have any doubt, you can measure. So all track distance is how much? 1 micrometer. So here also 1 micrometer. Here to here 1 micrometer. Here also 1 micrometer. We're just cross checking. So if you add all this, how many times is there? 5. 1, 2, 3, 4, 5. 5 micrometer. If you directly measure by a ruler. But by formula you are deriving. Understand or any doubt? Raya, you understood?
So otherwise understood, but sir, why is it only 6 tracks? It could be even more, right?
Yeah, it depends upon your device width. Okay, so they will try to, whether you work or not, they will cross check. So you will tell, suppose this width, generally PMOS width little bit more. So if PMOS, generally you have to take a 3 metal. If it is 120, suppose this is 128, this is your 240. So you can tell this is 2 track, this is 3 track. For tab 1 track, here 1 track. So total how many tracks? 7 track. Understood?
Yes, sir.
Yeah, this is just they will assume whether you work or not, because every devices have different size or length. So you can, it is not a same for all PMOS or NMOS should be same, depends upon width. So if your width is increased, track automatically it will be increased.
Generally for PMOS, since the width is more, so we take the number of tracks also is more than NMOS.
Correct.
Okay.
Why PMOS will be width? They will ask because of mobility. Understand? Na? So that I got it. Okay. So we have only 7 minutes left. So I'll just give you definition of an antenna. Latch up. So latch up just understood. The short circuit path created between VDD and BSS. Short circuit path. So a short circuit path will be created between VDD and BSS when a parasitic BJT will be formed. Parasitic BJT means NPN and ENP BJT will be formed. Again, I'm just repeating. Means there is a short circuit path will be created between VDD and BSS. So actually normal path, how current will be flow. This is your CMOS. PMOS and MOS. So current will be from, this is your VDD, this is your VSS. So this is your normal path. VDD to channel, through channel here. But there is a short circuit path between your BJT, VDD to VSS, when a parasitic BJT. Parasitic BJT means, okay, so you have to remember this diagram. So definitely they will ask this diagram to draw. Okay, so since we don't have time, I will draw, means it will take your 7 minutes. Let's up. So this is the draw. Okay, so you can go through how this BJT will from, that also I can tell. I'll just tell that one. Okay, so this is your PMOS. So P plus, P plus. So BJT will be formed. So this is your P channel, P plus. Annual is the base. This is your base. This is your collector emitter. Understand, P plus is a heavily doped, base is a lightly doped, collector is a moderately doped, or is like a C is the P substrate. So this is how they will ask which PNP. PNP, again I'm just repeating, emitter is P plus, annual is the base, collector as the P substrate. So this is your PNP. Then for here NPN. NPN is N plus, so P substrate, annual. So in between current will be flow. This is your latch up. To avoid latch up, we are drawing a guard ring. So when you in the run, you have seen latch up error. When you are adding guard ring, it will be clean. Understood? I'll just repeating this point because some people it is new. Parasitic BJT. Parasitic BJT, this is the term is a parasitic term. So short circuit path is creating between, this is the unwanted path creating between, because this current is passing through a substrate, NOL and P substrate. So there is a short circuit path between VDD and BSS when parasitic BJT will be formed. Parasitic BJT, parasitic NPN and PNP BJT. So PNP where it is creating, like P plus NOL and P substrate. Here N plus POL, then NOL, NPN. So due to this, a short circuit path. So mind arrow, you can see this is short circuit path is creating. So you have to draw this one. Just practice it. This is very important. They will ask definitely. Understand? Just take a screenshot. You can search the Google. You can find this point. How to avoid latch up. Even STI also second term. STI means is isolation because here PMOS is there. Here NMOS. In between STI, if you draw, STI, this is a fabrication case. You are not able to draw in the layout. So this is also how to avoid latch up. STA also will avoid as isolation it will give you. But main point is the gathering. Understand or any doubt? Up to now, any doubt? Okay, we have time, at least WP I cover. This will WP generally, it is a drawback. This is when you ask, because they will ask this is related to dummy. So generally in the matching device, VT variation should be same. Okay, so if you don't add dummy in the left and right side, your VT variation will be different. So I will take example that is called WP effect. So what is this? So we have 3 devices. Let's assume 3. Okay, this is annual. P substrate and so 3 PMOS is there. Annual when you create. So when they will create annual, that is called in 7-degree tilt, ion implantation will become. There is a specific reason in the rule. 7-degree tilt means some bending. So ion are coming like this. So this angle is 7-degree tilt angle. So ions are coming. So it will be, see this much one, you want annual only you want. So it will be touched here where this is a corner side. The region at this time, so it will be again, it will be bent like this, it will be deposit your electron. Like this annual will be created. It will be bent, then again it will be stop. So speed of the electron, it will be stop here, it will be stop. Because of this, the electrons are deposit in the corner, it will be more. Suppose here 100 number electron, here 200 number of electron. Here 100, here 100 number of electron. So uniformity, because of the, okay, some people are going to attend interview. So Ajay, Ashok, Limba, you are getting?
Sir, yes, sir, I have got.
Okay. So why you are telling? You can unmute.
Ion deposition at the corners, or it will be more deposited at the corners
Correct,
rather than in the
uniform middle side. Okay. So when you apply the VT,
yes.
so here the electron will be more. So more electron means you will require less VT. Its channel will be easily created. Understand? Or here it is electron. It is electron. Here you need a negative charges. So this is P plus na. So P mass. So you need more VT. Because here 2 number of electron, you need more VT. But here 100 number of electron, VT is suppose here 0.5. here 0.5, here 0.1. So this is the VT variation is occur. So to avoid this, what we are adding? We are adding dummy in the side. So if you add dummy side, so what will happen? This VT will be different. It will not affect. So it's 0.5 here, here 0.5. But in the middle device, it is 0.1. Understand? This 200
Sir.
will be caused at the nearer corner only. So corner only, if you add dummy, so it will not affect it. Okay, you people, what is the time interview?
Sir, 4, sir. I'll leave.
Okay, so we can stop. Just revise this topic. Okay, just go
Yes,
through.
sir.
Yeah. So all the best, all of you. Thank you.
Thank you, sir.
Don't need to be hurry. Even you don't know, you answer all the questions.